Okay, so based on that, let's take a look. First thing, when we have a quadratic function, the function actually will have a parent function of f of x equal to x squared. Now, what's it called? We just call it a second power normally. And then since that we have this, it's going to be linear equation. That's called first power. This is called quadratic equation. This is called cubic. This is called quadratic. And after that, we don't have much special names. So we only have these four as the most commonly seen. And then x to the 1 power, second power, third power, fourth power, all of these are called parent function because I do not have any of the coefficients at the front or any numeric addition at the very end. Now here, first thing, this is called our regular one. This is called our parent function. Okay, so far this is what we need to know. For quadratic function, and we're gonna have a parent function start with x squared. Now, what does a vector form is going to look like? So vector form, we'll have f of x equal to x, for example, let's say plus a, or maybe x plus b. Now, how does it work? These two are actually using foiling method to actually make it into a standard form. Okay, so in here, if we solve it, x equal to negative a, and here x equal to negative b. This is going to be our two individual answer for 0. Okay, so what was that doing? Okay, we're going to set the first one equal to 0, set the second parentheses equal to 0 individually, and then we're going to have two answers. Sometimes they might be including imaginary answer. That is perfectly okay. And then this is our vector form. Now let's take a look at a vertex form. Now what does vertex form do? We have a x minus h parentheses square plus k. Now what does it do? Why is it convenience for us? Oh, I'm going to go ahead and say that a is going to be our judging for happy phase or sad phase. That's called our manipulation. That means our leading coefficient. Now if I actually still h and I still k, put in the parentheses, that is going to be our vertex. That's our vertex. Now what else is important? Oh, x equal to h is going to be our axis of symmetry. That means that, pretend here this is our picture. That means that when I cut it down, that is going to be our axis of symmetry, and that is definitely going to be our h. That means in here, this specific question, our 8 or 7, I think it should be 7. 7 should be our axis of symmetry. Okay, so based on that, let's take a look at that. We have vector form, vertex form, and then last one should be a standard form. Okay, again, all of these should be in your notes for now. Okay, so in here I'm going to have a standard form, but what does it look like? Oh, normally what we've seen it almost every single day. This is actually a x squared plus bx plus c. Okay, what is it going to help us for? Oh, a is going to be our leading coefficient talking about our happy phase or maybe sad phase. C is going to be our 0, comma c as our y-intercept. And then if I'm talking about, what about b squared minus 4ac. That is our determinant. This is literally telling us that, if this is greater than 0, greater than or equal 0, then we have real answers. And then if this is, let me move down. If this is less than 0, then we're going to have two imaginary answers. Okay, so this is telling us that exactly how many answers do we have? Oh, we can actually have real answers or maybe imaginary answers. Now, this is called our what? Negative b plus or minus square root of b squared minus 4az and over 2a. What is that? This is a what formula? What's the formula?
Quadratic.
What is it solving for?
For x.
Yes, there we go. For 0. X is for zeros. Okay, so those are our answers. So these are the three different forms right here, talking about quadratic formula, And then there are 3 different form of them, and then they all have different method. They have different usage. Like what are they for? Why are these ones going to be convenient? So these going to be designated for 3 different things. Okay, so based on that, let's take a look. First thing, immediately judging by how it look like. What kind of form is that?
Standard?
Standard? Are you sure? Standard never.
No.
Parentheses.
Factor.
What is it?
No, wait. Vertex.
Vertex form. First thing, this is going to be vertex. It's looking like right here, vertex form. Why was that? Oh, because I have one parentheses only is belong to the x, and then with the square. That is our characteristic right here. So this y right here is a vertex form. So based on that, just by looking, what would be my vertex?
Your vertex, it's gonna be 3.
3. Vertex.
Yeah.
Vertex is still link H and K.
Oh. Then it's gonna be
Again, I'm going to label what they mean.
8 and 6.
8, comma 6. There we go. I'm going to have 8, comma 6. Okay, so based on that, that means I'm going to go ahead and draw this out. So I'm going to have 8 and 6 as my vertex. So it's going to be somewhere right there. Somewhere right there. 8, comma 6. Okay. And then I'm going to have a happy face or sad face based on the A.
You're gonna have a happy face.
Again, look at this one. -3. Am I going to have a happy face? I'm going to have what? This is a -3.
What? It is?
Look closer. This is a -3. So happy face or sad face?
Oh, yeah. Then why didn't they put the negative sign there?
This is a negative sign right there. So tell me, is a happy face or sad face?
Sad face.
Okay, so I'm going to have a sad face right there because there's a is -3 and -3 is less than 0. So I'm going to have a sad face. Okay, so based on that, I have a vertex and I already have that. Great. Now let's go ahead and take a look where else I can draw. Oh, okay, I'm going to have something that estimated looking like this. But to be more accurate, let me go ahead and find some points. And I'm going to plug in 7. I'm also going to plug in 6, 5. That's going to be easier. So if I plug in 5, f of 5, I'm going to have -3 times x minus 5. Oh, sorry, 5 minus 8. Oh, sorry, 5 minus 8 square plus 6. And then this -3 square, which is 9. So -3 times 9 plus 6. So -27 plus 6, which is -20. So I'm going to have somewhere like super down right there. So, okay, 5 is going to be -20. Let's go ahead and try 7. Maybe 7 is closer. It's going to be easier calculation. -3, 7 minus 8 squared plus 6. And then that's going to be a 1. So -3 plus 6, which is just a 3. So that means in here, if I have a 6 and a 7 and an 8 right here, if I extended it, 7, I'm going to have a 3, which is right here. That means if it's a 9, then I'm going to have something right here. That means it's going to be super sharp, sad face. Super sharp, sad face right here. Okay, so based on that, let's take a look. F has a greater maximum than G. Is that going to be correct?
No.
No, why was that?
Because, like, X is higher.
So F is smaller than G for the value right there. Okay, but what about second one? G is greater than the maximum than F. G is greater maximum than F. True or false? True or false?
This one.
G having greater maximum than F. Look at it.
True.
True, that is true. So in this picture, we have analyzed 7 as our maximum right here. This one is going to be a 6 as a maximum. So B is going to be correct. What about C?
C.
They said they're the same.
Okay.
Is that the same?
No.
Okay, so do you have all of these notes down in this page?
Yeah.
Okay. Okay, let's take a look at this one. Next one, and here, how many roots do a function have in common in here? So we have this is g again. That's one of the equation, and then f of x is equal to x squared minus 8x plus 16. There's another equation. So I'm gonna find out how many roots do they have. That means again the roots is gonna be the zeros, or sometimes we call it answers. So any of those. Okay. So based on that, we gotta make sure that we solve it. Now this is not very easy for us to find any of the x's because sometimes we gotta x's. How can we actually solve this one for x's?
We can solve it for the axis by using the formula.
But what formula? More specific, what formula? Are you trying to factor it? Are you trying to do a vertex form? Are you trying to use a quadratic formula? What are you trying to do?
I think it's quadratic formula.
Okay, quadratic formula works. Quadratic formula. Let's try. So negative b plus a minus b squared minus 4ac divided by 2a. So based on that, can you tell me what's a?
A is
Tell me what's a, what's b, and what's c individually.
individually A.
What's a, b, c?
A is x to the power of 2.
I want the coefficient of x of power of 2. So what's the coefficient for x of 2?
X
X to the power of 2. What is the coefficient in here? What's the hidden number right here? What should be the hidden number? Come on, William.
I don't know.
If nothing was written in any of the formula, so what would that number be?
0.
No, 0. 0 will make it gone. Not 0. What's another number? Not 0. In any linear, quadratic, cubic, quatic, literally any polynomial, a hidden number is always a number
1.
1. Exactly. So my a is just 1 because you have to make it exist. The only exist number is going to make it 1. Okay, what's b?
B is
Quick. What's b?
8. 8.
What kind of 8? Be more specific.
8x.
Nope. What kind of 8? Positive, negative.
Positive 8.
Oh, look at the question again, William. And pay attention in here. What kind of 8 do you have?
Negative.
Negative. What's c, William?
C is positive 16.
Okay, we're going to leave it there. So if I plug in, what's the negative b? If b is negative 8, what's negative b?
B is negative 8. Negative B is positive 8.
Yep, and then I plug in right here. And then what's b squared?
B squared.
B squared?
8 times 8.
Which is?
64.
Okay, minus 4, and then times a is just 1, and times c is times 16. 2 times a is just 2, so I'm going to leave it here. So there's 8 plus and minus. What is 64 minus 4 times 16?
64 minus 4 times 16 is
What's 4 times 16 first?
4 times 16 is 64.
So this is going to be 64. What is 64 minus 64?
0.
Okay, and then we have a 2. So that means in here I'm actually just have 8 over 2. What's 8 over 2?
A over 2 is
What's 8 over 2?
1 half.
8 over 2.
Oh, 8 over 2, 4.
4. There we go. So our final answer is just 4. Now, but the thing is, I'm expecting x squared. That means I'm supposed to expecting 2 answers, but because of that, well, I'm supposed to only have 1 point right here. That was it. So here is x equals to 4, and that was it. There's nothing else I can do. Now again, judge by the coefficient, because it's positive 1. Now again, 1 greater than 0, so I should have a happy face. So based on that, I should have something right here. I should have something right here. Regardless how it looked like, I should be touching at 4. I'm going to have a happy face right here. So based on the question, let's take a look. It says f and g share the same root. F and G share one root in common, but each have another root that is not shared. And C says F and G share no roots in common. What is the correct answer?
I think it is
Look in the picture, you have the answer. Look at the picture, you have the answer. William, look at the picture, you have the answer.
4.
4. So the thing is, based on this, how many roots are they sharing?
1.
1. So which answer is correct? William, stop clicking other things.
The answer is that correct is A. Wait, no. B.
B. They have one root in common, but another root that is not shared. Look at this picture. They literally curve on the same spot.
A.
Okay, so I think it's time to have to talk about the answer. So let's take a look at this one. What is counting as an answer? If I do have one touching point on the graph, that means I have one answer. 1, 0. Okay? And here, this is only 1 point because I supposed to have 2, but it's supposed to be like x equals 4, another x equals to 4. They duplicate it. Therefore, it show up as 1 point. But what about if I actually have another place that is giving me 2 spots? For example, if I have a curve looking like this, then I should have 2 spots. Maybe I have x equal to 0, then I have x equal to -5. Now I got 2 zeros. That is how we have 2 answers. We have 2 roots. That is how it looked like. But the thing is, if they both right here share the same thing, then that is called one root, one answer being shared. All good?
Yeah.
Okay, and another thing, look back in this equation. I have x squared minus 8x plus 16. Just by looking, we're supposed to think about a factor form faster. Okay, so look at this one. Right here. So something add up to 16 and then add up to a -8 and times to 16. Well, I have a 4 and 4 become 16, and then -4 and -4 become -8. So I should have -4 and -4. Look at this one. This will turn out as x minus 4 parentheses squared. Again, each of them solve into a 4. Each of them solve into a 4. Therefore, you will have duplicated answer in here. Now, in the future, you'll see something called multiplicity. If something that is actually have to be expected as a smiley face, then I should expect it to have 2 answers because of the second power. Now that means if I actually just do it right here and then creating like a hidden 1 situation, then that is called a multiplicity of even multiplicity. Okay? And then if anything that is, for example, I'm having a point right here and I'm actually going through, this specific point is actually either having no multiplicity or the odd multiplicity. So maybe sometime in here I will have something x to the third power, x to the fifth power, x to the seventh power, or maybe just x itself. So anything that is having a going through, that is actually called odd multiplicity. If anything that is hit and run, that is a even multiplicity. You can have x to the square, x to the fourth power, x to the sixth power, and so on and so forth. But in here again, why do I have one answer? Because I have a multiplicity of 2 for a quadratic equation. I have two a duplicated answer on the same exact spot. That is why we call them multiplicity. Cool?
Mm-hmm.
Okay. Now let's move on to the next question. Okay, in here, which function has a greater y-intercept? Just by looking immediately, we should analyze this answer already. How do you analyze y-intercept? What kind of form is that? How does it help you?
What crosses the y?
What crosses the y-axis? So this will cross it. Okay, so how would you know that where is the y-intercept and who has the greater y-intercept?
F has the greater y-intercept
Why?
because like the 4 in the back is like the y-intercept, and the graph is like showing it crossing the 3. So the F would have like the bigger one.
That is correct. First thing, in f of x right here, what kind of form was that used? What kind of form is it in f of x?
Standard.
Standard form. There we go. That's why in standard form, letter C, which is the last common term, is going to be your y-intercept. Next one. This is the last one in this quiz. So, how do the functions have the same concavity? Now again, concavity, do you understand what's concavity?
No.
Okay, concavity, usually we call it either concave up or concave down. Concave actually means that, oh, is that a smiley face or is that a sad face? This is called concave up, this is called concave down. Okay, so that is called concavity or concave. Okay, so first thing, just by looking, how would I judge the equation f, function f? How do I know the concavity? Immediately.
By seeing like the one which is
Which one am I looking at? 108, 4.
4x to the power of 2.
Okay, why am I looking at this box?
Because like it has
What kind of form and what does it talk about? What kind of form is this?
Standard.
Yes, this is going to be standard form. And then this is going to be our 8x squared, which is our leading coefficient. The leading coefficient.
I was trying to think of leading coefficient.
Yes. There we go. Leading coefficient that is greater than 0 is going to be a happy face. Leading coefficient that is less than 0 is going to be a sad face. And then if it's equal to 0, that's going to be like flat. Okay, so let's take a look. Well,
it's either A or C.
Okay, so first thing, this is going to be concave up because I'm happy. So in this f of x is going to be concave up. But looking, G is already a sad face. So what is going to be your answer?
C.
C. F is concave up and G is concave down. That should be the correct answer. Okay.